sorry, I forgot to to remove the overlay. Hey, how are you? Good morning or good night. It depends on the time zone you're watching us. Hi, my name is Alberto, and well, welcome back to this Global Hack Week AI slash machine learning. Um, I'm really excited to be back here. I had a session on last Friday, I think it was. Yeah, Friday. So I'm back for this week. Um, I like to start reading some comments because I love to see all your posts here on the comment section. Abhinav says hi. Aumi Duta says hi too. Mo Showa says hi everyone. Booster Plus, Hody Hody. Princess Geraldine, a hello. Hey from Anuya 189. Hello everyone from the great Sparkit Circus student. And well, I hope you already checked in, but I repost this. So in case you missed the check-in, go to events.mlh.io/events/1150 76, right? So, hey Sparks. So Busy Plow says hi to Sparks. World Satan Center. Hello, hello. Check in. Amazing. Thank you. Yes, I think that's for the checked in too. So yeah, thank you. So hellos. A morning from Chipotle. I think that's the thing you want to say. Is that correct? Chipotle. Despacito. Busuplaus 37 0. Um, do you speak Spanish or you just have Despacito in mind because of these trendy songs from some year ago? Despacito. I can't remember how it was, but yes. Shimari says, "Hey Alberto, hey Shimari, joining after months. That's amazing. Thank you for joining back. Good morning. I pitched in because of your name. How's my name here? Is Alberto from LH. Oh yeah, the Albert with the oh yeah, I get it. Good morning in the morning. Buenos dias. Amazing. So buenos dias for everyone, and buenas noches if it is your time zone. For me, it's up in the morning. It's 9 a.m. So I have some cold here. To be honest, it's too cold to wear. Evening, folks. So for you, it's evening. Hey. So enough for the comments for the moment. Again, but I love to see all your comments here. This session, it's not related with the previous one I gave about the theoretical introduction to machine learning, but we are going to discuss a lot of things that we saw in that session. And I'm saying it is not related because the main intention of the introduction to machine learning, it was to give an idea for those who don't have clear the picture of what machine learning and artificial intelligence in general terms is. So if you're currently in that position and you didn't watch that stream, go to the YouTube page from the Mailly Hacking and watch the recording. Not now, you can watch it later, because I have to say, well, an announcement. This session is going to be shorter than normally. Actually, we have to get. We only have 50 minutes right now before we have to run out of the session because it's going to be the today in Global Hack Week day. Which day is this? Day three? No, actually, no. Sorry, day four. But the time we don't get this session, we are getting the part two. I mean, that's later today in just 3 hours after the today in Global Hack Week session, time. So this part one is going to be shorter, but the part two it's going to be wider, right? So I see you again at 3 p.m. ET time. That will be around 1 p.m. for me. I don't know what time will be for you, but just I wanted to make that clear. Um, and in this session, we're going to again make use of the concepts we learn on the theoretical introduction. Not necessary, not mandatory to watch that, but I recommend you to watch it later if you didn't have the chance. And I see here, for example, it's Stephen also gave MATLAB intro classification algorithm last night. Yeah, that's amazing. I saw that. But this session is not going to be focused on classification algorithms. Actually, what we are going to do in this part one and part two, it's to use the pre-built MATLAB tools to create neural networks. So, doing a little recap and talking again about the whole panorama of artificial intelligence. Remember, there is artificial intelligence as the whole set of how to think. Um, let's think of this field of thought trying to replicate trying to replicate intelligence at all. And I think it's a little bit ambiguous because intelligence, well, you have to define it well. Then it's machine learning, which is a subset of artificial intelligence that tries to emulate that we learn. So the specific part of our intelligence that allows us to learn, it's the machine learning subset, right? Um, for example, there's um, a set of the other five. What's the word for this? Sorry, like seeing, while hearing, tasting, touching, sense. No, well, you understand me, right? Well, the thing here is we learn. So machine learning tries to emulate that and giving the ability to a computer to complete a task without us telling the computer how to, but not directly, but preparing it, giving a different idea of how to do it, the machine learning idea, right? So again, artificial intelligence, the whole universe. A subset it's machine learning, and a subset in that it's deep learning, for example, which it makes use of the neural networks, but they call it deep neural networks because they are complicated structures of a lot of layers to complete tasks. And for example, not all neural networks are deep learning. You can use deep learning. You can use neural networks in machine learning tasks. What gives the idea of deep neural network or deep learning? It's that we don't give the network the initial parameters, the main features for example, to be extracted from the information, from the data. The deep neural networks learns these key features itself, and we don't know how it does it, right? So it's like black box. Well, exactly, returning to this point, Stephen gave these classification algorithms, which is a part of the machine learning set. Um, and probably, well, I didn't watch the stream, but most classification algorithms are used in machine learning in a type called supervised learning. Sorry, I needed to remember supervised learning. There's three types of machine learning, which is supervised learning, unsupervised learning, and reinforcement learning. Actually, we are going to have a session on reinforcement learning tomorrow, but we are not doing that on MATLAB. We're doing that on Python. Well, things like classification can be achieved pretty good with supervised learning because you have a tag A and a tag B, and you need to tell the computer, for example, how to classificate another item with the tag A or tag B. In order to that, you need to give a lot of information, a lot of data to the model to be trained, and well, give the output of what this should be. This can be done with algorithms, for example, like in Stephen's scenario, with hash tables. Stephen mostly did k-nearest neighbor. Yeah, exactly. That's a great algorithm. And how it works is, for example, you have, for example, if you just want to classify two things, you have one axis from A and another axis for B, and you start putting points based on how close these things are to the idea. Then you train it. You have the whole model set, and once you put another one extra, well, here the idea is how many neighbors are closer to be type A or type B. Yeah, exactly. That's an algorithm, and that's cool. That's pure math, and that works, and it's counted as artificial intelligence, as machine learning, and etc. But the idea of the neural networks are another thing, and a lot of people misunderstand this concept. Even it was not that clear to me because I thought all artificial intelligence was neural networks, was fuzzy logic, and these types of things. And the truth is that they are not. For example, this algorithm, the key nearest network, it's not a neural network, but it still is machine learning, and it still count as artificial intelligence because these algorithms replicate the ability to think, the ability to understand, sorry, not to understand, to, for example, to predict, in this case, to classificate, which is something of intelligence. Well, what we are going to do in this session, it's purely talk about neural networks. And why is that? Well, because MATLAB has a neural network designer, which it's great. Like, it's one of the best tools I ever seen for these kind of tasks. Um, we were talking in this historical introduction that develop artificial intelligence as engineers, it's take these blocks, take these algorithms, manage data, put them together. It's heavy work, don't misunderstand me, but it's not creating the the complex stuff, because for me the complex stuff will be actually think of the algorithms, think how a neural network works, how they are going to be connected, how the interaction works, program that, like fully process it. That will be the heavy stuff. But nowadays, the panorama gives us that there are. activation functions. They are layers that are, how to say, like already built that, already there. So in the case of, sorry for the noise, in the case of ROS, we just need to take these layers, connect them, um, set some hyperparameters like how many epochs, which batch size, the input, how to say this, the input size, like the dimensions of an image, for example, of a vector. If we are going to talk about, um, for example, if you have text, you can input it as vector, etc., etc. Right. So, given this idea, the tools like Python and R, TensorFlow, PyTorch, and etc. We can create classes, we can call functions, we can do like this programming, which is great, and it's very intuitive. But most like that, a UI, like a graphical way of doing this, and like connecting blogs and etc. I think it's great. You will see it and you will love it. I hope. I see a comment here from for Fortnite found. I'm alive. That's amazing. How are you, Alberto? I'm really fine, thank you. I'm so glad to have you here. But also, I made some comments here. It's good night for us. From Int. Amazing. So, buenas noches. I don't know how to say this in other languages. Good night, buenas noches. No, no, I just have these two languages on my own. Um, Luis Fonsi and the Yankee, I Fonsi, Despacito. Okay, thanks for the lyrics. Any prerequisites for following this session? Yeah, and this is a very strong one. Not for the knowledge, because I will try to explain everything from the simplest to the most complicated thing I can handle. But the prerequisite is to have a MATLAB account and to have a MATLAB license. Remember, MATLAB it's not free. Good thing is if you are part of the Majorly Hacking community, they give you a tryout link like 3 months, I think. But I'm not sure that includes all the packages we are going to use. This specifically, sorry, it's a toolbox because packages in MATLAB are called toolboxes. This toolbox it's called Deep Learning Toolbox, right? So you can check it out. And well, that's the only prerequisite. Like if you want to follow, um, you have to have this MATLAB license. If don't worry, you can still take this session and watch it later once you sign up for the tryout account and etc. And well, yeah, just check it out. The more than the complex of coding, etc. Again, because this is a graphical thing, you will have you will get the idea. And I think this is one of the most valuable things about these toolbox for MATLAB. You can see how the training goes, like in every epoch, because it throws you graphics in real time. The you can move cursors, you can change parameters, and you see it in a graphical way. Well, this is very good. It's well built. Shubrati. Oh, nice. Shubrati. Good night, Lindy. Ratri. Okay. Thanks. Thank you. Because here's the correction. Okay. Let me start presenting my screen. And for this, I took um, the example. These examples are completely available on the MATLAB web, MathWorks. But we're going to make use of them. Here, you can see it now, right? We're going to make use of them to explain the bigger idea. Okay, for example, this is the code for creating a simple deep learning neural network for classification. Try Namaste. Namaste. Okay. Thank you. I heard that before, but I didn't know what does that refer to. Like, you can say it every time. Hello. Oh, it's like a hello. Like, I think it was aloha that means hello, but also goodbye. No. There was a word that meant hello, but also goodbye, but I can't remember if it was aloha. Okay. Returning to Dave Conrad comment, for example, about the classification algorithms. Well, this is not an algorithm, but this neural network is going to be made for classification. So this pipeline, let me open another thing. Just give me a second. This is the pipeline of a normal workflow um, working with artificial intelligence. We need data, which is one of the most important parts. Once we have this data available in our file, and this is specifically for MATLAB because it works kind of differently. For example, for Python, these first two steps will be the same. Like, we organize it once we import it. I don't know if that makes sense. Well, here we have to have available that data in our file, then we organize it and process it how we want it. For example, um, talking again about these images. Images, it's a great example because you can process it very many ways, right? For example, imagine you have picture of me right now, this square. Well, you have the resolution of the pixel of the picture, and then you have the depth of the picture. Because here you can manage a lot of things. I mean, images are complicated, right? You can put it. It depends of what you want to do, but you can put it black and white. So you have me black and white completely, then you can do it what pixel is white or closer to white, and what other pixel is black or closer to white, sorry, to black. And that in a scale, it depends again on you, from 0 to 1 or from 0 to 255. That will be one dimension, but we have a number of pictures of white and a number of pictures of height. Now, the thing is, this is just an image, but imagine you want to process images from faces. You have to define the same dimensional input for all your images. So the neural network can have the same input repeated over time, but for faces, maybe black and white will lost a lot of information because I have I don't know, like a different color of my lips than of my cheek, right? Or I have these different color of my eyes than other people's can have. and even for my feed, even for my thought, and that can give you information, valuable information. It depends on what you want to do. So there are different types of color systems. You have RGB, you have HSB, you have the MYK, and etc. and etc. It depends on what you want to do, right? But you pass from one dimension, well, a matrix of three, from three maxes, three matrices of the whole square. The red matrix, the the blue matrix, and the green matrix if you're using RGB, right? So these processing of the data is one of the most complicated things we can do in in how to say it, artificial intelligence tasks. For the sake of this uh, session, I am going to use the same uh, folder, or the same files they give here. And these files are already prepared to enter the network. And in this specific case, well, before passing to the example, let's return to explain the workflow. When we have our data processed and organized, and etc., we need to explore the data to give ourselves insights. I mean, these engineer features, this is marked as if needed, but I recommend to understand ourselves the data first. Maybe if I think it well, this should be even before the organize and process, right? But well, then you have to build the model based on that insights you get from the data. Then you have to evaluate it, and let's be honest, you won't have the best results at the first time. So you have to iterate over that, and iterate and learn and correct and make mistakes, but correct those mistakes, right? So finally, you have the model ready to use, and you can deploy it, right? So we can close this. We're good. So we, at this point, need to load and explore the image data, define the neural network architecture, specify the training option. This is what I was talking about the batch size, the number of epochs, the hyperparameters, and then train and get the prediction labels. To load this data here on MATLAB, we need to use the zip files. Let's open that. So, uh, 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 test, great. And this has folders from 0 to 9, because the data we are going to classify are handwriting numbers. In this case, we have separated already, and this is beautiful because you will see, if you will look for this information, for example in Keras or wherever you need or want to get this data set, that many of them are not classified yet, or not that structured like this. So we have this, okay, these tons of images about the number. In this case, this is a handwriting number. We can open this to see. It's loading, give it some time. There's a lot of information. Okay, don't worry. You can imagine. I'm going to open this in a second, but see the size. This is a 28 times 28 pixel image, same as all of the other images. This is what I was talking about, right? So in this, once I import the data. I have the data folder from the digits data. I need to create an image data store from data folder, including the subsequent folders, then meaning the 0, 1, etc. to till 9, and label source folder names. So this is my data store ints. Data store is a type of, well, a data structure here on MATLAB. You don't have to worry much about that. You can do it in many ways. And here we display what this folder contains. So let me run this again because this displays random numbers in a curricula. Mm, okay, I think I need to import them again. Okay, it's loading. Nice. Aloha means dear one in Hawaii. Loved one, maybe. Oh, then it is not what I was thinking. I think then it was in German, like choose. When you can say choose when you arrive, you can say choose when you leave. I'm so confused with languages right now, but thanks for the clarification about aloha. Thanks. Okay, now we have this. This is what the images contain, right? And this tells us that images are already procured to say in some way. Um, you don't get a dataset like this so often. You oftenly get, I cannot say like, many sizes of pictures. For example, if this is handwriting, the normal thing or the most usual thing to happen is that it is vice versa. You get a white background and a black number. Why this effect? Actually, it's up to preferences, but you can check the contrast, like what's going to be for you. Like you can totally change the background to white and the number to black and etc. But sometimes these image filters help more. And at some point, someone had to crop the image to fit the 28 pixels. And if you see it well, some of them are like blurred because maybe they were zoomed in a lot and they have to be tagged, right? So a person had to tag this as 0 and put it in 0 folder, and this as 1, and this as 1, and this as 3, and this as 4. But let's be honest, tagging these as 1, it's like, I don't know, if you ask me, I will say yes, it's a 1, but maybe it's not. Right? Or this one, I don't even know what this number is. This is really hard. And if you ask to me, like, if you ask an artificial intelligence, the artificial intelligence will say like, I completely don't know. If you tell me that's a 4, I will give that's a 4, but maybe it's a 6. I don't know. This is terrible handwriting, but it is possible. Let's run this again just to see what other things we have. Auf Wiedersehen in German for until we met again. That's a beautiful, beautiful word. Auf Wiedersehen until we see again. But it doesn't apply to when you arrive, right? Like you can only say that when you leave. Here, for example, we have like better numbers, but in this one here, I think it's a four again, but it's terrible. This one right here, I think it's a nine, but it's terrible too. Well, these processing images, it's complicated, right? Here, we need to calculate the number of image in each category. That means this cannot be an even distribution. Some datasets don't have equal number of tags per class, meaning that, for example, you can have 100 zeros but just 10 ones because people didn't write that many ones, etc. If you think of spam classification algorithm, the number of mails that are not spam will be much, much, much bigger than the number of mails that they are spam. So you can do many things in there. You can train the model with the accurate data, like pass the whole data being 10% spam, but 19% no spam. Or you can wait until you have a significant number of spam mails. I mean, in like 10,000, and pass 10,000 of no spam mails. That will be you have a balanced data set. Both have cons and pros. I mean, having to wait until you have 10,000 of spam mails, it's difficult. Um, there are we talk about this. There are like scenarios when you want to um, make synthetic data. Like for example, in these images, imagine we just have 100 of three images, like of the images of three, right? Of the number three, and we have, as we see here, 1,000 of the others. Like, well, we're facing an issue, right? Because the model can have a problem then identifying the number three based on the training data. Remember the common saying, garbage in, garbage out, because we if we pass garbage data to our model, then the model is going to predict garbage. It's going to give us garbage. We could do tricky things like manipulating the 100 images we have of the number three, like rotating them, like making a zoom in, then making a zoom out, doing proration of that images until we get the 1,000. But it's not that good. Remember, organic data, it's better than synthetic data. Well, in this case, we have the good result of having the data store containing 1,000 images per label, which is beautiful and makes our work simpler. In this case, we have a balanced data set. And then again, here the input of the layer should be the same every time. So we define it 28 by 28 pixel because all of the images are that format. Again, thanks for the data set. Not work needed here. If these conditions are not fulfilled, we need to make the data processing here, and that will take many time. So we specify the training and validation sets. That meaning, remember, we need to make partitions of our data set. What a partition is means that no single element in one subgroup will be in another one. I explained this more in the theoretical introduction, so if you want to check it out, you can go to watch the recording. We define the number of training files to be um, 750. The split image label will be the split image label function will give us the ims, the nums of the training file, and that will be completely random per file, storing them on the images to be trained and the image to validate this. Remember, there are different types of validation. Here we are just storing the training and validation ones. There are also training partitions and etc. that we can check later. For example, for holdout training validation, sorry, for a holdout validation or a key fold validation. In this case, we are just using images for training and images for the validation stage, which is this. We need to train the data, then we need to validate that training is good. After that, the best thing we can do is to test. And for that, in my opinion, one of the best things we could do is to test with the same dataset. But actually, we can hand grab a thing here and pass it, and that will be. Uh, let's try to do that. Well, and this is how define our neural network architecture. The layers, it's an array that will contain the image input layer defined for an input of 28 pixels times 28 pixels times 1 because these images are black and white. Remember, we talked about this at the beginning. The being black and white works perfectly for handwriting because we don't get a lot of data. But for many other images, like real life pictures, we lost a lot of information in just black and white. So then, if we want to work with RGB, for example, this will be a three dimension, but meaning the complexity of processing this increase many times. Then we add a combinational 2D layer. What's that? What's a combinational layer? Um, combinational means it takes, for example, the 28 times 28, and the parameter here says that takes 3 times 3. So the combinational layer it's going to make our images shorter. Then the batch normalization layer, the ReLU layer, it's the activation layer that it's going to tell whether the network is going to say this is happening something or the neuron activates or not. Then the max pooling, you can say the max pooling like the don't worry, we're going to explain these here. Here it's very well explained. Just take a look on how the architecture is. It's the input, then we have combinational with the normalization and ReLU. This is packed up. It's on purpose because actually, if we delete this works fine. But on purpose, we leave this space here for us to understand that this comes together in the architecture. Then we have the max pooling. Then another time we repeat this. Then the max pooling again. Then another time we repeat this. But take a look on how these parameters changes because first we decrease from 28 to 28 to three times, uh, that will mean this the next time we'll have that a decretion of three times um, in 16 pixels, and the last time it will be for 38 pixels. Then we just need to add the fully connect layer. This layer, what does is tell us where the classification goes, like just like for tagging, and that's it. Then the stuff mark layer, and that's the end of our architecture. Let's take a look of what this does deeply, right? The image input layer, it's where you specify the image size. In this case, is 28 by 28 by 1, and corresponding to the dimension of the pictures, right? For a columnar image, how we were saying, this channel should be 3, corresponding to the RGB values. Um, you don't need to shuffle data because trying it by default. Okay. Combinational layer. In this combinational layer, the first argument, the 3, it's the filter size. Let me look for an image for this to be more descriptive. Give me a second. Okay, I have this, and I think this helps to understand better. Oh, look, even with the number example here. So, for example, here we have the input image and accumulation layer. What it does, it's, for example, it takes the 28 but 28 and pass a filter. This filter it's be defined by this first parameter. In this first parameter, we say this is a three um, three layer, which means it's going to be a square matrix of 3 times 3. This is 1, 2, 3, like this very example, like this. Actually, this is like a convention. Normally we use these 3 by 3 filters, and what it's going to do is patch this filter, also known as the kernel, and check it with these first 3 times 3 parts of the image, and then pass it to an output. But what happens here? For example, in this example, this is 1, 2, 3, 4, 5, 6 by 6 image. Imagine that. Imagine we have a 6 by 6 pixel image. So when we define this combinational layer to be three uh, 3 pixels a square, what is happening here is that the image it's going to be reduced to a 2 times 2 um, dimension matrix, right? Because this pass here, then pass here, then pass here, and then pass here. Is that true? Well, it depends, because we can move this just 1 pixel to the right, then this will be 1, 2, 3, 4. That's happening here. Then move one to the bottom, that will be 1, 2, 3, 4. The same 4 columns, but how many rows? 1, 2, 3, until it fits perfectly. So not only the size of the kernel needs to be defined, but how many pixels it's going to move pass after pass, defining the output of the computational layer. Well, that's the other parameter. The filter size The number three indicates that the filter is size 3 by 3. This you can specify the second argument, it's the number of filters. Well, in this case, not only the, well, we have one filter, but in this case, we're specifying 8 filters. And the padding, it's the interesting here. The padding may value arguments the input feature for the map. Size of one same ensures that the spatial output size is the same as the input size file. Okay, this is weird, but they use for this specific architecture, and this can change depending on your needs. But the padding it's same because sometimes we need to add um, how to say it. If you comes from web programming, you know what a padding is, and it's the same. We need to add a padding in order for the output to don't change. So imagine this is the real data that you have, and the output was decreased. That's correct, right? But if we add a padding of just zeros on the corners, like a zero here, 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 a zero here. Two columns were added and two rows were added at the top and at the beginning, at the left and at the right. This padding, what does is that replicates or makes the output equal to the original input, not the padding one. The padding was wider and with a bigger height, right? But the original containing the real data was this size. We add the padding with just zeros for the filter to make the output the same size at the output. Let's look for the width padding. Here, 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 here. Beautiful. Let's wait for this to open. So this is what is happening. This 3 times 3 square, in this case the kernel is 2 times 2, but this 3 times 3, okay, now this is not the same output. Okay, I think this one. 1, 2, 3, 4, 5, 1. Yeah. So this animation explains the thing I was doing. If we have the padding, when we pass one step one, one step one, one step one, one step one, we're moving forward. The output will be is the same size as this input, because remember the original input it's the file containing here, or the matrix, sorry, containing the numbers. We add the padding in order to have the output the same size. And why is that? Is there a way to get MATLAB for free? um, Yes, we give you a license here on the Merely Hacking for use it for 3 months. But then after that, I'm sorry, the answer is no. Um, your institution can check for that for providing. For example, I have MATLAB for thanks to my institution where I study. And well, that's it. Um, Okay, returning to this accumulation layer. You may be thinking, why then the padding? Why adding this to be the same? Well, the truth is that a 28 times 28 pixel matrix, it's very short. It's a very small matrix. So in these images, you already see this blurred. Like we cannot see the edges in a sharp way. If we reduce this, every combinational layer of the network, we will end up with a very, very small image. Plus, when we make a computational process for these layers, the normal thing is that mirror to that, like for example, if we apply 1, 2, and 3 combinational layers, then we need to decombulate that to get the output to be the same size. So thanks to the image input, it is short. Okay, I am running out of time, so I will hurry up. Thanks to the image input that it's short, we not or we set to the padding to be the same as the output. And that's 3 times until we extract the features. So thank you. Yeah, no, thank you. Gently remind me about the time can hardly wait for the next trip. So we are going to okay, that bleep. Okay, we are going to pause this right now. Remember, this was part one. I sorry about the time, but we are going to take that time back on part two. See you 3 p.m. ET time. So, so sorry. Okay, see you back in a couple of hours. Bye bye.